Hello, everyone. Welcome to section 10.3, part 2. In this part, we're going to go ahead and look at some examples of using matrices to solve linear equations. So to do that, let's go ahead and look at an example. Let's say we wanted to solve a system maybe like 4x minus 3y plus z equals -8. And then maybe we want to do -2x plus y minus 3z equals, let's do -4. And then x minus y plus 2z, equals 3. Okay, so if we want to solve this using matrices, the first step is we want to take the system and write it as an augmented matrix. So we're going to write a matrix recording sort of the coefficients. So I think this is going to be 4, -3, 1, -8. So that's the first equation. And for the second one, we get -2, 1, -3, -4. And then 1, -1, 2, 3. Okay, so this is our augmented matrix. So our second step is easy to say, not so easy to do. We want to perform elementary row operations to this to write the matrix in row echelon form, or better yet, reduced row echelon form. In order to do that, we're going to kind of do the same sort of thing that we did with systems of linear equations, where we were sort of like looking at the first or all the x's, and we want to cancel out the x's below that, right? So we're going to actually end up doing the same sort of process. So if we look at this first column here, I want to make it so that there's a 1 at the top and zeros below it. Because there's already a 1 here, it's easiest just to go ahead and move that 1 up to the top, rather than trying to force the 4 and that line into a 1. I don't want to deal with fractions, so I'm going to go ahead and swap them. So we'll just swap the first and last rows. And when we do that, our matrix becomes 1, -1, 2, 3. So that was our last row above. And then the middle row stays the same. And our last row becomes 4, -3, 1, -8. Okay, so now let's get cooking for real. We want to look at this first column, and we want to cancel out the numbers underneath that 1. So let's go ahead and look at that -2 first. To get rid of it, I'm going to go ahead and take my first row, I'm going to multiply it by 2, and I'm going to add it to the second row. So when I do that, if I do 1 times 2 is, so here, let me record the first row first, because that one is unchanged. Okay, now 1 times 2, so that's 1 times 2 is going to be 2, plus -2 is going to be 0, so that's 0. And then -1 times 2 is -2, plus 1 is going to be -1. And then we've got 2 times 2 is 4, plus -3 is going to be +1. And then 2 times 3 is 6, plus -4 is +2. And then the last row stays the same. Okay. We're looking at the first column again. We got that 0, that's good, but now we need to get rid of that 4. So to do that, I'm going to multiply this row by -4, and I'm going to go ahead and add it to the last row. So when we do that, the first and second rows stay the same. And then our last row, we get 1 times -4 is -4, plus 4 is 0. And then -1 times -4 is +4, plus -3 is +1. And then we get 2 times -4, that's going to be -8, plus 1 is going to be -7. And then 3 times -4 is 12, plus -8 is -20. Cool. So now we've got that 1 and all zeros below it. So now we're going to go ahead and narrow down our focus, and we're going to look at the second column right here. So there's a couple of different ways you could do this. They're all kind of the same. I'm just going to go ahead and multiply the middle row here by -1. And the reason I'm going to do that is because that -1 right here will turn into a +1, which is much easier to work with. It's what we want. So if I go ahead and do that, our matrix becomes same thing in the top row. In this row, we get 0, +1, -1, and then -2. So that's multiplying -1 through that row. And then the bottom row stays the same. Okay, so now looking back at that little square right there, I want to take the one in the middle row and I want to use it to cancel out the one in the bottom row. So I'm going to multiply this by -1 and add it to that one right there. So when we do that, top row stays the same. The middle row also stays the same. And for the bottom row, 0 times -1 is 0, plus 0 is still 0. So there's a 0 there. 1 times -1 is -1, plus 1 is 0. And then we get 1 plus -7 is going to be -6. And then we get +2 plus -20 is going to be -18. Gorgeous. Okay. So now we've got leading 1, zeros below them. That's good. So now all we need in the last row to get this into to get this into row echelon form is we want this thing to be leading 1. So what I'm going to go ahead and do is I'm going to go ahead and divide this bottom row by -6. So when we do that, it's the same thing as multiplying by -1/6. We do that, our matrix becomes same thing in the first and second rows. We get 0, 0, right? 0 times whatever is still 0. -6 times -1/6, that's going to be +1. And then if we divide -18 by -6, I think we get +3. And hey, look at that. This is indeed in row echelon form because we've got a 1, a 1, and a 1. So we've got leading 1s, and we've got zeros below them, and they are in that cascade pattern. So this is row echelon form. And from here, we could go ahead and go straight to step 3. We could translate it back into a system of equations, right? So we get that 1 corresponds to an x, the -1 is a -y, 2 is +2z, and then 3 is equals 3. And then we get a y minus z equals -2, and then we get a z equals 3. And so from here, you can just go ahead and back substitute as we were doing previously. Or if you wanted to be a little fancier about it, we go ahead and take this matrix that we have and we could make it into reduced echelon form. And I'll show you why that it's a little bit nicer in just a minute. So if we were just to take the matrix that we had above, so the 1, -1, 2, 3, 0, 1, -1, -2, 0, 0, 1, 3. If we wanted to make this into reduced echelon form, we want to get rid of we want to make 0 the entries that are above the leading ones. So that -1's got to go, and so does that -1 and that 2. So in order to do that, we're going to do the same sort of thing that we were doing to get rid of the numbers underneath the ones, just kind of going up instead of down. So I think let's go ahead and just focus in on this column first. So that -1 is a problem. In order to get rid of it, I think we can just take this middle row and add, because this middle row's got that 1 there. We can just add that 1 to -1. That'll get us 0, right? So when we do that, 0 plus 1 is still just going to be 1. And then we get 1 plus -1 is going to be 0. That's what we wanted. And then we get -1, that right here, plus 2 is going to be +1. And then -2 plus 3 is also going to be +1. And then the other 2 rows stay the same. Cool. And so now we have zeros above that one as well. That's good. So now all we need to do is narrow our focus down on this column. Okay, we're going to use, we want to use this one to cancel the ones above it. So I think what I'm going to go ahead and do is I'm going to take that bottom row and I'm going to add it to the middle row. In the same kind of move we did just a second ago. And so when we do that, we get 1, 0, 0, 0, 1, 0. I guess I should actually write this like in the actual order it is. So the first row stays the same. And then the second row, 0 plus 0 is still 0, 0 plus 1 is still 1, 1 plus -1, that's going to be 0, and then 3 plus -2 is going to be 1. And the bottom row stays the same. Cool. So now, looking at this column again, we got that 0 in the middle place. That's good. Now all we got to do is take care of that 1 that's on top, this one right here. So to do that, I think I'm going to multiply this row by -1, and then I'm going to add it to that row. So if we do that, we get 1, 0, 0. I keep doing that, just bad habit. So we get 1, 0, 0 plus 0 is still 0. And then we get -1 plus 1 is 0. And we get -3 plus +1 is going to be -2. And then the other two rows stay the same. We get 0, 1, 0, 1, 0, 0, 1, 3. And now we are in reduced echelon form because here are our leading ones. We've got zeros below them. We've got zeros above them. And they're in that cascade pattern. Everything looks good. So this is in reduced echelon form. And the reason that this is a little bit nicer is because when we translate it back to a system of linear equations, as in step 3 of this process, we see that the 1 is an x, 0 for y, 0 for z, so another variable, and then equals -2. That's pretty slick. Okay, what about the second one? We get 0, so no x, and then 1 for a y, 0 for z, so no z there, and then equals 1. And then for the last one, 0, 0, so no x's or y's, and then 1 for z, and then equals 3. You don't have to do any back substitution. The solution's already there. It's just x equals -2, y equals 1, and z equals 3. So that's why reduced echelon form is nice. You don't have to do any back substitution. That work is already kind of done for you behind the scenes. Okay, cool. So that was an example of using a matrix to solve a system of linear equations. Before we go, let's go ahead and do the same process, but maybe with something a little bit bigger. Maybe with something that we wouldn't want to try to use our earlier techniques to solve systems of linear equations on because it's too big. So let's say we wanted to solve this monstrosity. Let's say we wanted -x plus 2y plus c minus 3w equals 3. So we've got 4 variables here. The fourth one is that w. And then maybe we also have something like 3x minus 4y plus c plus w equals 9. And then maybe like a -x minus y plus z plus w equals 0. And then we got like a 2x plus y plus 4z minus 2w equals 3. Okay, so this is pretty gnarly, but let's go ahead and use a matrix that'll be a lot cleaner. So let's go ahead and write down our augmented matrix. We get a -1, 2, 1, -3, 3. And then a 3, -4, 1, 1, 9, -1, -1, 1, 1, 0. And lastly, we get a 2, 1, 4, -2, 3. Okay, so just as before, we're going to focus in on this left column. And we want to get a 1 up there in the top left corner. There's no 1 in the column, so I'm not going to swap anything, but there's a -1 already there in that left-hand corner right here. So I'm going to make that a 1 just by multiplying that whole row by -1. So when we do that, our matrix becomes 1, -2, -1, +3, -3. So we flip the signs on everything. -3, -4, 1, 1, 9, -1, -1, 1, 1, 0, 2, 1, 4, -2, 3. Okay. For both your sake and mine, I'm going to go ahead and speed this process up a little bit. So you notice that when we did like multiply a row and add it to the others, we were only changing one row at a time. So we can kind of write down the steps all at once. That's perfectly fine. So if we're looking at this first column, I want to make that 3, that -1, and that 2, I want to cancel them out. I want to make them 0. So to do that, I want to take the first row, multiply it by something, and add it to those. So for the second row, I'm going to multiply it by a factor of -3, and I'm going to add it. And for the second, or not the second row, sorry, the third row, I want to multiply it by, this isn't very clear. Hold on. Let's see if I can make this a little bit better. So for that third row, I want to multiply it by a factor of, let's see, we've got a 1 and a -1. So actually, we don't need to multiply it. All we need to do is just add. And then for the last row, I think I need to multiply it by a factor of -2 to cancel out that 2. And then I'm going to add it. So if we do all these steps at once, we can be really, really slick here. So that first row stays the same. And so that second row, you multiply 1 by -3, we get -3 plus 3 is 0. And then -2 times -3, that's going to be 6 plus -4, yeah, is going to be 2. And then similarly, I think we get like a 4, and then maybe a -8. And then we do -3 times 3, that's going to be +9 plus +9 is 18. Okay, and then doing the same things for the other two rows. So we take the first row and we just add it to the third one. 1 plus -1, 0. -2, -1, that's going to be -3. -1 plus 1, that's going to be 0 again. 3 plus 1, that's 4. And -3 plus 0 is -3. And then for that last row, I'm going to multiply by -2 and add it. So 1 times -2 plus 2, it's going to be 0. And then -2 times -2 plus 1, that's going to be 5. So we got 4 plus 5, or sorry, 4 plus 1. My mouth is getting parched. Okay, -1 times -2, that's going to be +2 plus 4 is 6. And then I think similarly, 3 times -2 plus -2 is going to be -8. And then -3 times -2 plus 3 is going to be 9. That's 6 plus 3. Okay, so in that move, we have this column here. It's got 1 and 0s below it. That's good. That's what we're going for. Okay, so now we want to take a look at this column right here, these entries. I want to take that second row that has that 2 there. I want to make that a 1, just because it makes the math easier. And in fact, we see that we've got a factor of 2 in all the other entries of that row. So if we divide out by 2, all the numbers will be nice, which is good. It doesn't matter to the matrix if the numbers aren't nice, but it matters to me because I don't want to work with fractions just as much as I can, just because they can get really, really messy in a matrix really fast. So I'm going to multiply this whole thing by 1/2, the same as dividing out by 2. And when we do that, top row stays the same. We get 0, and then we get 1, 2, -8 divided by 2 is going to be -4, and then 18 divided by 2 is 9. And then the other 2 rows stay the same. Okay. So now we've got that 1 there. We can really start to work with it. All right, so I want to cancel out that -3 and that 5. So to do that, I think I'm going to take the second row. I'm going to multiply it by 3 and add it. And I'm going to take the same row, that second row, I'm going to multiply it by by -5 to cancel out that +5, and I'm going to add it. Okay, so when we do those, top row stays the same. We get the second row also stays the same. We're not doing anything to it. And then for this row, we do 0, and then 3 plus -3 is 0. 6 plus 0 is 6. We get -12 plus 4. That's going to go ahead and be -8. And then we get 9 times 3 minus 3. I think that works out to be a +24. Okay, cool. And then for the last row, we get a 0 still, because 0 plus 0 is 0. And then we get -5 plus 5 is 0. And then in the other two slots, I believe we get a -4, a 12, and a -36. Okay. So now we've got this one and zeros below it. That's good. So now what we want to do is we want to focus on this one. It makes it easier if we can get a 1 somewhere in this little yellow box I just made. I think it's actually easier to get a 1 from the bottom row because 4, 12, and 36, they'll have a factor of 4 in them, right? So if we divide by -4, we'll get a 1. So let's go ahead and do that. Multiply by -1/4, same thing. When we do that, all the other rows are unchanged. Zero, 0, and then we get 1, and then I think we get like a -3, and then in the last entry we get a 9 when you divide that out. Okay, so now we got a 1 here. I want that to be above for it to be row echelon form, so I'm going to go ahead and swap these out. When we do that, the other two rows are unchanged. There's a little ambivalence about what's going on here. Okay. We swap them out, we get 0, 0, 1, -3, 9, and then we get a 0, 0, 6, -8, 24. Okay, so now we can go ahead and do what we were doing earlier. We want to cancel out that 6. To do that, I think we want to multiply this by -6 and add it. And when we do that, the other two rows are unchanged. Zero, 0, 1, -3, 9, and we get a 0, 0, and then -6 plus 6 is 0. And then if we do -3 times 6 plus -8, I think that works out to be eventually 10. And then -6 times 9 plus +24, I think that works out to end up being -30. Okay, so now we've got that 1, zeros below it. That's good. We're almost there for row echelon form. So this last row, we see we got like a 10 and a -30. I want to make that 10 a 1, right? So I'm going to go ahead and multiply this row, or I'm going to divide out by 10, right? So multiply by 1/10, same thing. And when we do that, the other rows do not change. Oh, sorry. Going too fast. So 10 divided by 10 is 1, and then I think we get -3. All right. So this is in row echelon form. Now you could go ahead and translate it back into a system and back substitute if that is what you'd like to do. I'm going to go ahead and keep going with finding the reduced row echelon form, just so you have another example of what that looks like and how it's done. So if we do that, looking at this matrix, if we just go ahead and look at this first column first, we want to take this one and we want to cancel that -2 above it. So to do that, I'm going to multiply this row by 2 and I'm going to add it to the first row. So when we do that, let's go ahead and speed this process up a bit. I think we get 0 plus 1 is just 1, and then we're going to get a 0 here. And then if you do the math out, I think we get 3, -5, and 15. And then the other rows are unchanged. Okay, now we're worried about this column right here. I want to take this 1, I want to cancel that 2 and that 3 above there. So I'm going to take that third row, I'm going to multiply it by -2, and I'm going to add it to the second row. And for the first row, I'm going to multiply that third row by -3 to cancel that +3, and I'm going to add it. So when I do that, like the first row, the 1 and the 0 are unchanged, and then we get a 0 instead of the 3. That was by design. And then I think we end up getting a 4 and a -12. And for the second row, we get 0, 1. Those are unchanged. And then I think we get 0 by design. And then the other two entries, I think, are going to get 2 and a -9. And then we do 0, 0, 1, -3, 9, and 0, 0, 0, 1, -3. Those two rows are unchanged. Okay. So to finish this off, we're looking at this column. I want to cancel out that -3, that 2, and that 4 with that 1 that's on the bottom there. To do that, I think I'm going to multiply the row by 3 and add it to the third row to cancel out that -3. And I'm also going to multiply it by -2 and add it to cancel out the +2. And then I'm going to take that last row and I'm also going to multiply it by -4 and add it to cancel out that +4. And when we do that, we get 1, 0, 0. Those columns are unchanged because it's just 0 on the bottom row. And we're just going to be adding 0, so nothing happens. And then we get 0 here, kind of by design. And then when we do -3 times -4, that's going to be +12 plus -12, that's 0. That's perfectly okay. Sometimes that happens. And then we get 0, 1, 0, 0. And then I think this becomes a -3. And then we get 0, not 1, 0, 0, 1. And then I think when we do that, we get 0 by design. And then when we do -3 times 3, we get -9 plus +9 is going to be 0. Okay. And then the last row is unchanged. So this is in row reduced echelon form, or sorry, reduced row echelon form. So now when we translate this back into a system, we have 1 and then all zeros. So this is just going to be an x equals 0. And then we get 0 for x, a 1 for y, zeros for the other variables, and then -3. So y equals -3. And then 0, 0, 1, 0, that's just going to be a z equals, and this is 0, so it's going to be 0. And then 0, 0, 0, so no x or y or z. There's a 1, so there's going to be a w. And then there's going to be equal -3. So here the solution is going to be 0, -3, 0, -3. Cool. So those are some examples of using matrices to solve systems of linear equations. Now, just like when we were doing systems of linear equations, there were special cases where we would get like no solution or infinitely many solutions, right? When we were dealing with just lines, this was like when the lines were parallel or when they were like on top of each other. The same kind of thing can happen for, well, the same kind of thing can happen for systems with more variables. So, but let's look at what that kind of looks like in matrix form, because it can look a little bit different. I mean, it'll look familiar, but it's good to kind of write it out and see what it looks like when it's in that kind of grid. So if you're working with a matrix, And you end up zeroing out a whole row. So like if you were like, trying to get rid of the number underneath the 1, and it just happened that all the other numbers also went away, and so you just get a row with zeros. So if you got something that looks like 1, 5, 0, 2, and then maybe we get 0, 0, 1, 3, and then if we had like our bottom row is all zeros, when you get something that looks like this, then the system has infinitely many solutions. This is just like when we were dealing with equations and we wrote 0 equals 0, right? In matrix land, we say the system is dependent. That's the word for it. Now, on the other hand, if you're working with a matrix, and you get all zeros in a row, except for the rightmost entry. So what I mean by that is if you have a matrix that maybe looks like 0, 1, 3, 4, and then maybe like a 0, 1, 2, 5, and then maybe you've got like 0, 0, 0, 2. Now it's okay if the 2 was somewhere else. So if this happens, this is not what I'm talking about. I mean when it's 0 everywhere except for the very right entry. So when you have a matrix that looks like this, you really have 0 equals 2, and you have no solutions. I wish I could spell. Okay, in this case, when you have no solutions, we say the system is inconsistent. Okay, and that's kind of it for using matrices to solve systems of linear equations. They can feel really clunky because there's a lot of little arithmetic that you have to do to work with matrices, but they're much better than trying to work with the equations directly. So once you get the hang of matrices, they're quite nice. And they're very important to a whole bunch of modern math. So yeah, just keep practicing at it. It'll get better as time goes on. And of course, let me know if you get stuck anywhere.